finding the derivative of a function. This is a quadratic function, but we've been doing this all along. So to find the derivative, f prime of x equals the limit as h approaches 0 of, let's just get right into it. What will f of x plus h look like initially, Bridget? Perfect. So f of x plus h, she had to plug x plus h into both spots. The x plus h that's getting squared and the x plus h that's going to get multiplied by 3. Minus f of x, I'll just copy that down as is. All over h. And then we just start ironing this out. So on the numerator, I'm going to square the x plus h. I'm going to distribute my positive 3. I'm going to distribute my negative. All over h. So just simplifying out, and a lot's going to clean up on the numerator. X squared minus x squared for 1 is gone. Positive 3x minus 3x is gone. And I only have 3 terms in the numerator now, none of which can be combined, but all of which have an h. So each and every one of those 3 terms can be divided by h. And that will leave me with 2x plus h plus 3. And now I can actually take the limit of that by letting h be 0. We can assume h is 0 now because it doesn't give us an indeterminate. So that'll give us 2x plus 3. And again, that was our f prime of x formula. That's it. That's the derivative. Use the derivative to find the slope of the function at x equals negative 2. So that's just going to be f prime at negative 2, which is going to be 2 times negative 2 plus 3, which is going to be negative 4 plus 3, negative 1. Oh, you're the best. Yeah. Thank you. And then also at negative 3 halves, so f prime of negative 3 halves, 2 times negative 3 halves plus 3. That 2 and that 2 will cancel. It'll be negative 3 plus 3, which is 0. What shape was this function again? Aiden? A parabola. So just out of a point of interest, we just found that at the location of negative 3 halves, the slope was 0. Where on a parabola is the slope 0? The vertex, right? So just by chance, we actually just realized that the vertex is at negative 3 halves. So when the derivative equals 0, here's a big takeaway. When the derivative equals 0, it's like a kind of a flattened section of one, or, you know, in a parabola, it'll be like a vertex. In a polynomial equation, all of these spots will have derivatives equal to 0. If we look at something like this, like a wiggle kind of thing, right there, believe it or not, is a slope of 0 if it's kind of wiggling through a number, which we will see. I'm trying to think where else the slope is 0. M equals 0. M equals 0 to all of these spots. Can you think of another graph where the slope would equal 0? I don't know if I can think of one off But those are the most common types. At maxes and mins, or at like little, like with triple roots, we used to call those squiggles. Is that what you guys called them? Do you remember? I'm getting my algebra 2s and my pre-calcs messed up because we do that triple root wiggle stuff in all of them. But anyway, and then just again, as a point of interest, getting smarter and making sure I don't grab the calculator that's got the bridge on it. If I were to graph this x squared plus 3x, I just thought of an interesting activity that I want to try. Your slope at -2 would be right there. We can all agree that that's right here is at -2. That's kind of a negative slope, right? And we got a slope of -1 there, so that makes sense. And then at -1.5, which is where the vertex is, the slope is 0. Yes? Do you remember how you used to find the vertex? And not used to as if we won't do it ever again, but how do you find the vertex from that standard format? If the equation is ax squared plus bx plus c, how do you find the vertex? You could change the format, definitely. But there was a quick little formula that gave you the x-coordinate of the vertex. Yeah. Negative b over 2a gives you the x-coordinate of the vertex. So hopefully that sounds familiar to all of you. From this equation, negative b would be -3. Over 2a would be over 2. -3 over 2 would be the x-coordinate of your vertex, which is exactly what we just found there. Yes? So here's the activity I want to do. I'm a little nervous that once I get into it, it might be a little over your head. It might be a little premature for this activity, but you don't need to write this down. Let's just write this. If my function were ax squared plus bx plus c. So I'm giving you a very generic function. And we all know that the vertex is going to be, is when f prime of x, when the slope equals 0. Agreed? We just kind of discussed that. The vertex of a parabola is going to happen when this f prime at that location is 0. When the slope there is 0, okay? So let's actually find the derivative of this. So f prime of x is going to equal the limit as h approaches 0 of f of x plus h, which is going to be pretty long, minus f of x all over h. And f of x plus h is going to look like this initially. I got a lot of work to do on that, but that's f of x plus h when I plug in x plus h, minus f of x all over h. So, excuse my laziness, and I'm not going to write that limit 1,000 times over. But the first thing I would have to do here is square the x plus h, keeping an a out in front. Distribute my b. Distribute my negative. Okay, good. Now I can distribute my a since I squared that already, so that'll be ax squared plus 2axh, that's a mouthful, plus ah squared plus bx plus bh, the rest is just going to follow. Now what cancels? Ax squared with a minus ax squared? Positive bx with a negative bx? And a positive c with a negative c. So I am again left with 3 terms up top. all of which have an h, so I can divide each by h. So my derivative is now going to be the limit as h approaches 0 of 2ax plus ah plus b. And when I find that derivative by letting h be 0, it's going to be 2ax plus b. That's my derivative, right? And back to this whole vertex idea, which is what I'm sort of examining now. Our vertex is going to be when this derivative equals 0. It's going to be the x location when the derivative equals 0. So if I solve this for x, watch what happens. Subtract my b over. Get x all by itself, divide by 2a. So the x location where the derivative will equal 0 is negative b over 2a. Fascinating, right? I love that. I don't even think I knew until I started teaching this class why that formula negative b over 2a worked. I just, like you guys, your teacher tells you, here's the formula you use to find the x-coordinate of the vertex, and you just use it and say, thank you, some genius, for figuring that out, and you just use it and go on with your life. But once we learn about derivatives and a little bit more about calculus, you can see where that actually came from, which is just gets me very excited. I know. Nate, not so much. You don't look pumped. No. Not, like, on a scale of 1 to 10, like, how, like, at least, like, could you say, like, it's a little cool. Like, scale 1 to 10, where would we go? A 4. All right, so there's a little appreciation, but at the end of the day, we just not, we don't, like, math doesn't really fascinate you that much, huh? All right. Who here is math your favorite subject? Raise your hand if math is your favorite subject. Maybe all of you. So for you, 4 or 5, was that somewhat cooler than a 4? Like a 7? Oh, come on, Andrew, you're too cool for school. Like a 7? Like, all right, that's what people who like math like tend to appreciate about math. It's like, oh, I get it. No. Okay. John, you're dreaming of Hawaii. Don't even. Next one. I went on my tangent. Find the derivative of, this is x cubed. It didn't really copy great because there's a little speck on the paper. But this is a cubic function. So x cubed minus 2, we're going to find the derivative of that first. And then we'll use the derivative to do whatever they're asking. So let's find the derivative first. F prime of x equals limit as h approaches 0. F of x plus h is going to look like something minus f of x all over h. So Bailey, what's f of x plus h going to look like initially? Perfect. Minus the f of x exactly as is, all over h. Now, cubing x plus h is not a treat. This is what we hate about math on the flip side, all of us, me included. I can do x plus h squared, obviously, in my head. But that's still going to have to be multiplied by another x plus h before I can subtract the 2. I can distribute the negative if I want right now. Minus x cubed plus 2. Here's what I want to definitely discourage you from. Even though our focus really for the moment is in cubing the x plus h, don't write half of the problem down. Like, don't just write this down and focus on that and then try to remind yourself where you were in the whole process, because you'll lose things. You'll forget to copy down the minus 2 or something, or you'll forget this whole second part. You'll forget the whole minus f of x part. So always be complete with it. I know it's more writing, but it's just going to keep everything very organized. And then handle this Yes, you wasted time writing that again, and you're just going to have to keep copying that over, but keep it there. When you get to the next step, we're going to distribute x squared times x plus x squared times h. Then distribute your 2xh plus 2xh squared. Then distribute your h squared plus h cubed. Well, at the time, we can at least get rid of the minus 2 plus 2. Minus x cubed. All over h. Limit stays out in front just for accuracy reasons. And then when we simplify that, the x cubed minus x cubed cancels. Nothing else cancels, but things combine here. So x squared h, and then I have 2x squared h's. Any more x squared h's? No, no, no. So that's 3 of those total. And then I have xh squared, 2 of them. And then another one of them, xh squared. So that's 3 of those. And then I have an h cubed. All divided by h. The good news, and what almost always happens, is that whatever terms are left in your numerator, you'll notice, and you probably remember this from earlier in the year when we did difference quotient. Whatever's left in the numerator, almost always, those all have h's, so you can just divide an h out of all of them and get rid of this fraction. So that would be 3x squared h plus 3xh. Oh no, that h is not there. 3x squared, because this h cancels with the bottom. 3xh, because one of those cancels with the bottom, plus h squared. Good? Now we can assume that the limit, well, we can find the limit, and we can actually assume that h can be just infinitely close to 0 here. So that'll give us 3x squared. That'll be plus 0 plus another 0, so it's just 3x squared. So your derivative formula is just 3x squared. That'll give us the slope at any x value. This will always be what, by the way? No matter what x you plug in, when you square it, it will become positive. When you multiply it by 3, it's going to still be positive. So this derivative is always positive, which means the slope of the function is always positive, which means the slope of the function is increasing constantly, right? Except for at 0, it's not technically positive, but the point is it's never negative, right? So if you now use this derivative to find the slope at -1, so f prime of -1 would give us 3, and f prime of +1 would also give us 3. I think the point of me asking you to check those two is just to kind of talk about that always increasing thing. So also on this one, now it will always be positive except for when x is 0, right? At 0, what will the slope be? 0. Now, when you look at this graph, which is a cubic function shifted down 2, at 0, the slope is 0 because it's one of those like little wiggles that we have. It's like a triple root kind of thing. It's just that it's been shifted down 2. Okay, so when the derivative equals 0, doesn't have to be a max or a min. It can be one of these wiggle kind of scenarios. Okie doke. Okay, we flip to the back. Find the derivative of this. This is just going to be a little bit nasty because you have decimals, but you'll get through it. And then let's just do this one because it's kind of bringing a radical back into it. So again, I would recommend you find f prime of x first, right through the end, and then just plug in a 2 at the very end. I wouldn't try to plug in a 2 for x right away. Let's just focus on f prime of x equaling the limit as h approaches 0 of f of x plus h. What will f of x plus h look like, Mitch? He didn't really, plus 2. So he just copies this down but replaces the x with x plus h. Minus f of x is root x minus 1 plus 2 all over h. Now again, forgive me because I'm going to be lazy and I'm not going to write this limit thing over and over again for the sake of time. But when I go to do this, it's going to be root x plus h minus 1 plus 2, and then when I distribute my negative doesn't go through the radical, it just goes in front of the radical. It still is an x minus 1 underneath, but it does do the minus a positive 2, which will be minus 2 all over h, which is lovely because your 2's cancel. But then here's where we're at. Root x plus h minus 1 minus root x minus 1 all over h. I still can't plug in an h of 0 yet. I'll get 0 over 0. So my manipulation calls for what here? Rationalizing. So to rationalize here, Sarah, what would I multiply by? Perfect. Over itself. Okay, so in my numerator, when I FOIL, the radical times the radical will just cancel the radical. It'll be x plus h minus 1. My outer and my inner will cancel because they'll be opposites of each other. And then your negative root x minus 1 times your positive root x minus 1 will be a negative, right? And then your radical will cancel, but be careful. Your radical is canceling, leaving a binomial. Well, there's a subtraction sign in front of that binomial. So very much be careful when you get to that. And your denominator, we're not going to FOIL out because that's not what we were rationalizing. So the intricacies of the algebra are extremely critical here. If your algebra skills are weak and not perfected, like how to FOIL these things and so forth, some of these problems get really ugly. I mean, it's just algebra, but it's algebra intensive for sure. So when I go to simplify my numerator, this x minus this x will cancel, and this negative 1, and then this will turn into a plus 1, that'll cancel. So your numerator will just be h. And then h over h can cancel, and it's 1 over and now we can finally find the limit as h approaches 0. So if h is approaching 0, it'll be 1 over root x minus 1 plus root x minus 1, which makes 2 of them in the denominator. 1 over 2 of these root x minus 1s, and that's your derivative. And to find that derivative at 2, just plug in 2. F prime of 2. So that's like one of the most algebraically intensive we've seen so far. Okay? So same page for homework, just now the next section, 15 through 27 odds. Your quizzes. Not going to. You're the best, Abby. I was going to, but she saved me. Bailey, will you pass these out for me? This scale was a nice one. So 10 questions, they would normally be worth 10 points each. Here's how I did it.